A tan might make you look leaner, but is there actually something deeper going on? Could sunlight itself influence how your body stores and burns fat? In this video, I'm breaking down what the research says about sunlight exposure, metabolism, and a lesser-known hormone called Alpha-MSH. Of course, a tan naturally adds definition and makes muscles appear more prominent. That's just contrast and lighting. But beyond the visual, there are a few biological mechanisms worth exploring. When your skin is exposed to sunlight, a whole cascade of biological processes kicks off. UVB light helps produce vitamin D, which has been linked to improved insulin sensitivity. UVA exposure stimulates the release of nitric oxide from the skin, which plays a role in vasodilation and glucose uptake. UV also triggers a hormone called Alpha-MSH, short for alpha-melanocyte stimulating hormone. That's involved in tanning but also appetite and energy regulation. But here's something important. In nature, sunlight never comes in isolated wavelengths. You are not just getting UV, you are getting infrared, visible light, and the full spectrum. These different wavelengths work together in ways that we are only beginning to fully understand. When we isolate just UV light, like in artificial tanning beds, we may be disrupting that natural balance. Some research suggests that without the protective and restorative effects of infrared and red light, isolated UV exposure could cause more cellular stress or DNA damage. This is why safe, balanced sunlight exposure is key. Think early morning light, short midday doses, and avoiding overexposure. We are not saying go sunbathing for hours, but we are looking at how the right kind of exposure might support your body in ways beyond skin deep. Alpha-MSH is produced in response to UV exposure. It increases melanin, that's your tan, but it also acts in the brain via the melanocortin system, particularly MC4 receptors. Studies in animals and humans have linked this system to appetite suppression, increased energy expenditure, activation of fat-burning pathways such as lipolysis and thermogenesis. For example, mice lacking the MC4 receptor tend to gain weight easily without even eating more. It's not just UV. Near-infrared light, which is also part of sunlight, has been shown to influence mitochondrial function, potentially boosting ATP production and metabolic efficiency. Some studies suggest it may even increase mild mitochondrial uncoupling, though this is still an area of ongoing research. There is also interesting research showing that nitric oxide, released from the skin during UVA exposure, might help glucose enter muscle cells without insulin through GLUT4 transporter activation. This could be one way that sunlight indirectly supports blood sugar regulation and insulin sensitivity, though more studies are still emerging. So does being tanned cause fat loss? Not directly, but there are some fascinating links in between sunlight exposure, hormonal responses, and metabolic regulation, particularly through pathways like alpha-MSH and nitric oxide. If you found this type of metabolic science interesting, hit the like, share with a friend, and subscribe for more content that connects movement, mindset, and metabolism. And if you are curious on how to take a full body inside-out approach to transformation, including nutrition, lifestyle, and training, feel free to check out my one-on-one 12-week transformation program. Details are in the description. See you next time.